Hi guys, welcome back. Myself Akshayan. I'm currently pursuing my BE in SVCI Bangalore. My topic is overview of structural testing and statement testing. Introduction to structural testing. Structural testing is a type of software testing that examines the internal structure of software applications. It involves testing the code itself to ensure that it functions correctly and meets the specified requirements. This type of testing is also known as white box testing or glass box testing. Importance of structural testing. Structural testing helps to identify defects in the code that may not be apparent through other types of testing. It ensures that all parts of the code are tested thoroughly, leading to a more robust and reliable software product. By uncovering issues in early development process, structural testing helps to reduce the overall cost of bug fixing. Types of structural testing. Some common types of structural testing include statement coverage, branch coverage, and path coverage. Statement coverage ensures that each line of code is executed at least once during testing. Statement coverage is a crucial metric in software testing that measures the extent to which the lines of code in a program have been executed by test cases, providing insight into the thoroughness of testing efforts. Coverage verifies that all possible branches in the code are taken during testing. More types of structural testings are path coverage, condition coverage, and loop coverage. Path coverage tests every possible path through the code, ensuring that all logical conditions are met. Condition coverage focuses on testing various conditions within the code, such as if statements and loops. Loop coverage ensures that the loops in the code are tested for all possible scenarios. Tools for structural testing. There are many tools available to assist with structural testing, such as code coverage tools and static analysis tools. Code coverage tools are essential components in modern software development and testing workflows designed to assess the thoroughness of test suites by measuring how much of source code is executed during testing. These tools provide quantitative insights into the extent to which tests cover different aspects of the code base, helping developers to identify gaps in test coverage and prioritize areas for improvement. Static analysis tools are software tools used in field of software development to analyze code without executing it. They operate by scanning the code for patterns, structures, and behaviors that might indicate errors or inefficiencies, providing developers with actionable insights to improve code quality and maintainability. Best practices for structural testing. Test coverage metrics. Measure and aim for high coverage metrics such as statement coverage, branch coverage, and path coverage. Unit testing. Begin with unit testing where individual units or components of software are tested in isolation. This helps identify defects early and facilitates debugging. Integration testing. Conduct integration testing to verify that units work together as expected. Use of code analysis tools. Employ static analysis tools to identify potential issues in the code base, such as code smells and potential bugs. This can help in improving code quality before executing the tests. Boundary value analysis. Test boundary conditions of input parameters to uncover potential off by one errors or other boundary related issues. Equivalence partitioning. Divide the input data into equivalent partitions and test representative values from each partition. Mutation testing. Apply mutation testing to assess the quality of existing tests. This technique introduces small changes into the code base and checks if tests detected changes. Code reviews. Conduct code reviews to identify issues and ensure code quality before testing. Test automation. Automate structural tests wherever possible to ensure consistency and repeatability. This includes automating unit tests, integration tests, and regression tests. Continuous integration. Integrate structural tests into a continuous integration pipeline to ensure that the tests are executed regularly and consistently with each code change. This helps in catching issues early in development lifecycle. Test data management. Manage test data effectively to ensure that tests cover a wide range of scenarios and edge cases without relying on production data. Challenges of structural testing. Structural testing can be time consuming and resource intensive, especially for large and complex software applications. It requires a deep understanding of the code base and ability to create effective test cases. Maintaining test coverage as the code evolves can be a challenge requiring ongoing effort and coordination. Automation in structural testing. Automation can help streamline the structural testing process by running tests quickly and efficiently. Test automation tools can be used to automate the execution of test cases and generate reports. Automated tests can be integrated into continuous integration process to ensure code quality and stability. Impact of structural testing on software quality. Structural testing plays a crucial role in ensuring the quality and reliability of software applications. By identifying and fixing defects early in the development process, structural testing helps to prevent issues in production. A comprehensive structural testing strategy can lead to higher customer satisfaction and reduced maintenance costs. Limitations of structural testing. Structural testing focuses on the code itself and may not uncover certain types of defects, such as requirements or design flaws. It can be challenging to achieve 100% test coverage, especially in complex software systems. Structural testing may not detect issues related to performance, scalability, or reusability. Introduction to statement testing. Statement testing is a white box testing technique that focuses on ensuring each statement in the code is executed at least once during testing. This type of testing helps identify gaps in code coverage and ensures comprehensive testing of the software. Statement testing is essential for detecting errors that may occur due to missing or improperly executed statements. Importance of statement testing. Helps in identifying dead code or unreachable statements in code. Provides a measure of code coverage, indicating how much of the code has been executed during testing. Ensures that all statements in the code are tested, leading to more robust and reliable software. How statement testing works. In statement testing, test cases are designed to execute each statement in the code at least once. The test cases are created based on the analysis of the code structure and flow. The goal is to ensure that all the statements, including conditionals and loops, are tested under different scenarios. Techniques for statement testing. Statement coverage ensures that each statement in the code is executed at least once during testing. Branch coverage extends statement coverage by also ensuring that each possible branch of conditional statements is executed. Path coverage tests all possible paths through the code, including loops and nested conditionals. Benefits of statement testing. Identifies unexecuted code. Statement testing helps identify code that has not been executed by any test case. This is crucial as unexecuted code may contain defects or logic errors that remain undetected until tested. Enhances code confidence. Achieving high statement coverage increases confidence in the code base by ensuring that most lines of code have been exercised. This reduces the likelihood of bugs or unexpected behavior in untested code paths. Improves code quality. By systematically testing each statement, statement testing encourages developers to write clearer, more modular code. It also facilitates the identification and elimination of redundant or unreachable code segments. Measures test effectiveness. Statement coverage serves as quantitative measure of test effectiveness. It allows teams to track the percentage of code covered by tests and identify areas that require additional testing or refinement of test cases. Early detection of integration issues. During integration testing, statement coverage ensures that interactions between different components or modules are adequately tested. This reduces integration risks and improves overall system stability. Promotes continuous improvement. By regularly measuring and monitoring statement coverage, teams can identify trends over time. Customer satisfaction. Ultimately, statement testing contributes to delivering higher quality software products that meet or exceed customers' expectations. Reduced defects and improved reliability to lead greater user satisfaction and trust in the software. Challenges in statement testing. Designing test cases that cover all possible code paths can be time consuming and complex. Ensuring that all statements are executed may require creating a large number of test cases. Maintaining test suites for statement testing can be challenging as the code evolves. Best practices for effective statement testing. Use automated testing tools to generate test cases and analyze code coverage. Prioritize testing of critical and complex code segments. Regularly review and update test suites to accommodate code changes. Common pitfalls in statement testing. Focusing solely on statement coverage without considering branch or path coverage. Over reliance on manual testing leading to human error and inconsistency. Neglecting to update test cases as the code base evolves, leading to outdated tests. Limitations of statement testing. Statement testing may not always guarantee the absence of defects in the code. It may not be effective in identifying certain types of errors, such as integration or performance issues. Achieving 100% statement coverage may not always be practical or necessary in all scenarios. Conclusion. Testing is indispensable for identifying and fixing defects in software. It ensures the reliability and functionality of applications before they reach users. Comprehensive testing enhances user satisfaction by delivering seamless experience. By detecting issues early, testing reduces the overall costs of development and maintenance. It plays a critical role in achieving software quality and meeting business objectives effectively. Structural testing is a critical component of software testing process, helping to ensure the quality and reliability of software applications. By examining the internal structure of the code, structural testing can uncover defects that may not be apparent through other forms of testing. Incorporating best practices, automation, and continuous improvement can enhance the effectiveness of structural testing and lead to better overall software quality. This was all about overview of structural testing and statement testing. Thank you.